For billions of years, our solar system has been a dynamic and sometimes violent place. Amongst the planets and moons, countless fragments of rock and metal hurtle through space, remnants of cosmic collisions and the very building blocks of our planetary neighborhood. These celestial travelers, when they cross Earth's atmosphere, ignite in a fiery blaze, becoming shooting stars. But sometimes, a piece survives the perilous journey, landing on our world as a tangible link to the cosmos, a meteorite. Every night, the sky tells a story. Hidden among the stars are travelers from the vastness of space, ancient fragments older than Earth itself. When they fall, we call them meteorites. These cosmic messengers have shaped landscapes, influenced cultures, and even changed the course of life on our planet. This is their story. Meteorites are solid pieces of debris from space, often from asteroids, sometimes from the Moon or Mars, that survive their fiery journey through Earth's atmosphere. But not all that falls from the sky is the same. Scientists classify them into three major groups: stony meteorites, iron meteorites, and stony iron meteorites. Meteorites are more than just space rocks that fell to Earth. They are time capsules, offering scientists invaluable insights into the early solar system, the formation of planets, and even the potential origins of life. They begin their journey as meteoroids, small bodies orbiting the sun. When a meteoroid enters Earth's atmosphere, friction causes it to heat up and glow, creating a meteor, often called a shooting star. If a portion of this object survives its fiery descent and lands on the ground, it is then known as a meteorite. The vast majority of meteorites originate from the asteroid belt, a region between Mars and Jupiter teeming with rocky debris. Collisions between asteroids can send fragments hurtling towards Earth. Some meteorites, however, have more exotic origins, blasted off the surfaces of the Moon and even Mars by powerful impacts. By analyzing their composition, scientists can often trace meteorites back to their parent bodies, unlocking secrets about these distant worlds. Stony meteorites are rich in silicates, resembling terrestrial rock. Iron meteorites, composed mainly of metallic iron and nickel, often display striking crystal patterns known as Widmanstätten figures. And then, the rarest of all, stony iron meteorites, dazzling mixtures of metal and silicate crystals, as though forged by alien hands. The journey through Earth's atmosphere is a brutal test for any space rock. Traveling at incredible speeds, meteoroids encounter immense friction, causing their outer layers to heat up to thousands of degrees Celsius. This intense heat creates the brilliant streak of light we see as a meteor. Most small meteoroids completely burn up in the atmosphere. Only the larger and more resilient ones survive to reach the ground, often breaking apart and scattering along their trajectory. These surviving fragments are what we ultimately find as meteorites. For as long as humanity has gazed upward, meteorites have inspired awe and fear. To the ancient Egyptians, iron from meteorites was metal from heaven, shaping tools and jewelry long before iron smelting was known. Across cultures, falling stars were seen as omens, messages from the gods, signs of war, death, or fortune. From Inuit hunters forging knives from meteorite iron to Chinese chroniclers documenting fireballs, these sky-born stones left their mark not only on the land, but on the minds of those who witnessed them. But meteorites are not only curiosities. Some have changed the course of history itself. 50,000 years ago, a massive iron meteorite slammed into what is now Arizona, creating the mile-wide Barringer crater. Today, it stands as a reminder of Earth's vulnerability to cosmic impacts. 66 million years ago, an asteroid impact near present-day Chicxulub in Mexico wiped out the dinosaurs, altering the path of evolution. Without that collision, humans might never have walked the Earth. These events remind us, while meteorites may be rare, their consequences can be cataclysmic. On February 15, 2013, the world was reminded of our fragility. A 20-meter meteor exploded over Chelyabinsk, Russia, with the force of 30 Hiroshima bombs. Over 1,000 people were injured, yet the meteor was small by cosmic standards. The largest meteorite ever discovered, the Hoba meteorite in Namibia, weighs an astonishing 60 tons. Unlike most, it never formed a crater. Its sheer size slowed it down before impact. In the icy deserts of Antarctica, meteorite hunters scour the white landscape. Black stones on the ice are easy to spot, and the continent has yielded thousands of specimens, unlocking secrets about the solar system. Locating meteorites on Earth can be a challenging but rewarding pursuit. Certain environments, such as deserts and frozen ice sheets, are particularly conducive to finding them, as the dark rocks stand out against the light background and are preserved for longer periods. Meteorite hunters utilize a keen eye, metal detectors, as many meteorites contain iron, and scientific knowledge to identify these extraterrestrial visitors. Each find offers a potential new piece of the cosmic puzzle. Meteorites are invaluable resources for scientific research. By studying their mineralogy, chemical composition, and isotopic ratios, scientists can learn about the conditions and processes that prevailed in the early solar system. Some meteorites contain organic molecules, the precursors to life, sparking fascinating questions about the potential for life beyond Earth. They also provide clues about the formation and evolution of planets, including our own. And then, the rarest discoveries of all, meteorites from Mars and the Moon. These samples, blasted into space by ancient impacts, traveled millions of kilometers before landing here, giving us pieces of worlds we have yet to fully explore. While most meteorites are small and relatively harmless, larger impacts have played a significant role in Earth's history. Giant meteoroids colliding with our planet can cause widespread devastation, shaping landscapes and even influencing the course of evolution. Studying ancient impact craters helps us understand the potential risks and the dynamic relationship Earth has with the cosmos. As we look to the skies, the question remains: could a devastating impact happen again? NASA and international space agencies are watching. Programs like DART, Double Asteroid Redirection Test, are humanity's first attempts to defend itself from the cosmos. While small meteorites fall daily, the true threat comes from larger asteroids, capable of regional or even global catastrophe. Detecting them, tracking them, and learning how to divert them may one day decide the survival of civilization itself. Meteorites are more than rocks. They are storytellers, carrying tales of creation, destruction, and survival. They connect us to the cosmos, reminding us that Earth is not an isolated world, but part of a vast, dynamic universe.